Hello friends, today we are going to learn about industrial heat exchangers, their types, and the maintenance procedures that are undertaken to manage their efficiency and prolong their work life cycle. So let us begin. What is a heat exchanger? A heat exchanger is a device designed to transfer heat between two or more fluids without allowing them to mix directly. It enables the transfer of thermal energy from a hot fluid to a cold fluid, or vice versa, through a solid barrier or sometimes by direct contact, depending on the type of exchanger. This process allows heating or cooling of fluids efficiently while keeping them physically separated to prevent contamination. Heat exchangers are widely used in various industries such as HVAC, power generation, chemical processing, refrigeration, oil and gas, and manufacturing. Their main function is to regulate temperature, improve energy efficiency, and ensure safety by controlling heat flow in processes. Now we are going to see the common types of heat exchangers that are used in the oil and gas sector specifically. First one is the shell and tube heat exchanger, the most prevalent type in the oil and gas industry, consisting of a bundle of tubes inside a pressurized shell. One fluid flows through the tubes, the other around them, enabling efficient heat transfer. They handle high pressures and temperatures and are widely used for crude oil preheating, cooling, steam generation, and refining processes. Second one in this sequence is a plate heat exchanger. It is composed of stacked, corrugated plates that create alternating hot and cold fluid passages. Their compact design provides high heat transfer efficiency, suitable for space-restricted areas and moderate pressure applications in oil and gas processing. Third one here is a double pipe heat exchanger. It consists of one pipe inside another, with fluids flowing in counter or parallel flow directions. They are simple, easy to maintain, and are used for smaller-scale heat transfer tasks in the industry. Fourth one here we have is an air-fin cooler heat exchanger. It uses ambient air to cool process fluids, eliminating the need for cooling water. The fan cools the fluid flowing through the tubes either based on the induced cooling or forced cooling method. They are common in petrochemical plants and the power generation industry, where water is available in scarcity. Fifth in line, we have here a spiral heat exchanger. It features spiral channels that promote turbulent flow, which reduces fouling. They are used in some oil and gas applications for viscous fluids that are prone to fouling. Sixth one is a fin tube heat exchanger. It has tubes with fins to increase surface area for heat transfer and is often used in gas cooling applications within the sector. Then we have a plate and shell heat exchanger. It combines plate and shell designs, offering high heat transfer rates, high pressure and temperature resistance, compact size, and low fouling advantage. The type of heat exchanger is selected based on process requirements such as fluid type, temperature, pressure, space availability, and fouling tendencies. Shell and tube exchangers remain the dominant choice due to their robustness and versatility in the oil and gas industry. In this section, we will discuss the maintenance procedure of industrial heat exchangers that ensures efficient heat transfer, which in turn reduces operational costs and prevents unexpected failures in the long run. The key maintenance activities can be seen here. 1. Regular inspection. Visual inspection for fouling, corrosion, and mechanical damage is performed by an experienced technician. He monitors inlet and outlet temperatures, flow rates, and pressure drops to detect performance degradation. Pressure relief valves are checked, and it is ensured that the pressure is safely released before any maintenance activity. 2. Cleaning and descaling. Mechanical cleaning methods, such as rotary tube cleaning or projectile cleaning, are used to remove deposits from the inner sides of the tubes. High-pressure water jet cleaning is the most common type of cleaning method which is used to clean the body and internals of the heat exchanger thoroughly. Chemical cleaning using specialized cleaners can be applied with steam injection to dissolve fouling and grease without shutting down the plant completely. Cleaning procedures often involve circulating hot water and cleaning agents through the exchanger to ensure all surfaces are treated equally. Regular cleaning prevents scaling, fouling, and corrosion, which reduces the heat transfer efficiency of the heat exchanger. Next comes repair and replacement. Here, the damaged tubes, tube sheets, or gaskets are replaced to restore performance of the heat exchanger. Welding or patching cracks and leaks with appropriate techniques is performed to maintain the overall structural integrity. Bolts and suspension wheels are lubricated for ease of maintenance and adjustment. After the maintenance part, we have testing activity. Here the pressure, temperature, flow rate, and efficiency tests are conducted to verify proper functioning of the heat exchanger. Hydrotesting of the equipment and several non-destructive testing methods are conducted to ensure no leaks or blockages remain within the system. Testing ensures that heat transfer performance is restored close to its original levels. Now we will discuss about the maintenance plan. Regular preventive maintenance is scheduled to avoid unscheduled downtime of the equipment. Computerized maintenance management systems, CMMS, are used to track maintenance activities and predict failures. In refineries, some heat exchangers require more frequent inspection due to material wear or fouling, while major shutdown inspections occur after several years. We can have a glance at the maintenance plan here. You can pause the video and go through the tabulation. Next comes safety precautions and safety checklist. It is ensured that the system is depressurized and cooled before maintenance to minimize exposure to hot fluids. Proper safety relief devices are used and safe cleaning practices are utilized to avoid any hazard. The technicians are fully covered with all the necessary safety gears which protects them from any hazard. A standard safety checklist format is shown here for your better understanding. In this section we are going to discuss the most common type of fouling in heat exchangers which reduces its heat transfer efficiency, incrustation. It is the accumulation of crust or coating from processed fluids, minerals, or cleaning agents on heat exchanger surface. Scaling, a specific type of incrustation caused by mineral deposits such as calcium carbonate, calcium sulfate, and silicates, common in hard water applications. Sediment, particulate fouling deposition of suspended particles like corrosion products, metal oxides, silt, alumina, microalgae, and their excrement, which block flow paths and impair heat transfer. Biological fouling, growth and attachment of microorganisms such as bacteria, nematodes, protozoa, and sometimes larger marine organisms, forming insulating layers. Chemical reaction fouling, formation of deposits due to chemical reactions within the fluid, such as coking, cracking of hydrocarbons, or polymerization. Corrosion fouling, fouling caused by corrosion products forming on the heat transfer surface itself, which can degrade material and performance. Solidification fouling, occurs when liquids solidify on subcooled surfaces, e.g. ice formation. Now we will discuss the impact of fouling on heat exchangers. Fouling in heat exchangers has significant economic impacts on industrial operations, especially in energy-intensive sectors like refineries and power plants. The main economic consequences include increased energy and fuel costs. Fouling creates an insulating layer on heat exchanger surfaces, reducing heat transfer efficiency. As a result, more fuel or energy is required to maintain process temperatures, leading to higher operational costs. For example, heavy fouling can increase fuel consumption by up to 20% in power plants, and even a thin-scale layer, 0.6 mm, can cause a 40% rise in fuel use in steam boilers. Higher maintenance and cleaning expenses. Frequent cleaning and maintenance are necessary to manage fouling, which incurs labor, equipment, and cleaning agent costs. In the UK, annual cleaning costs for heat exchangers have been estimated at around £500 million. In many industries, up to 15% of all factory maintenance costs are attributed to heat exchangers, with half of that due to fouling. Increased capital expenditure. To compensate for anticipated fouling, companies often install larger heat exchangers than would otherwise be necessary, raising initial capital costs. Fouling-related capital costs can account for up to 15% of total heat exchanger expenses. Productivity and throughput losses. Fouling impedes production by reducing the ability of heat exchangers to maintain optimal process conditions. This can lead to lower throughput and lost revenue. For instance, a refinery might see a 10% reduction in output due to fouling, which translates to substantial financial losses. Equipment replacement and downtime. Severe fouling can cause equipment failure, requiring costly repairs or replacements and resulting in unplanned downtime. These interruptions further increase the overall cost of fouling. Environmental and compliance costs. Increased energy consumption due to fouling leads to higher emissions and potential environmental compliance costs. This can also affect a company's ability to meet regulatory requirements. In this last section, we can have a glance on the material selection process for heat exchanger fabrication and their use in respective sectors. Depending on type of industry, process requirement, and available budget, the client selects the specification of the heat exchanger to be purchased. Heat exchanger is one of the most common equipment which goes under maintenance in large numbers in a refinery. Hence, in every shutdown maintenance, the contractor receives a favorable number of heat exchangers for maintenance activities along with other static equipments. In the coming videos, we shall explore more about other types of equipments and their maintenance activities. For the time being, we will conclude this video here. For further information and insights, you can access the blog mentioned in the description below. Thank you, friends, for being till here. Have a great day ahead.